So in a previous video, we were reading through this etcd FAQ page, and here we've stopped at a pretty thick question. It says, what does the etcd warning etcdserver API v3 RPC transport http2 server dot handle streams failed to read frame and then a read connection reset by peer mean? Okay, so what does all of that mean? Well, this is a gRPC-side warning when a server receives a TCP RST flag with client-side streams being prematurely closed. For example, a client closes its connection while gRPC server has not yet processed all HTTP2 frames in the TCP queue, and some data may have been lost in the server side, but it is okay so long as client connection has already been closed. In only old versions of gRPC log this. etcd version 3.2.13 by default log this with the debug level. Thus it's only going to be visible with --log-level debug flag enabled. Okay, so let's go to these two links real quick. Here on GitHub, we have server error reconnection reset by peer under stress. What version of gRPC are you using? What version of Go are you using? What operating system and version? And what did you do to get there to that error, right? And on July 10th, 2017, they said this looks like a log spamming on the server side, which would be fixed by this, and that is not actually an error. So here, use log severity and verbosity level. All logs use one severity level instead of printf, and then all transport logs only go to verbose level 2+. The default logger only log errors and verbosity level 1. Add environment variable. So these two to set severity or verbosity levels for the default logger. And then that other link brought us to etcdserver log stream error with debug level, silence gRPC server info level logs. etcdserver logs were getting too verbose when there are lots of canceled streams. Also silence gRPC info level server logs. And then here's a reference link. This person says LGTM looks good to me. So here we are back at the FAQ. There's a performance section. I have a separate video where I read documentation from this website about performance and a little bit about the benchmark tool. The link takes us here, and we can read a little bit. Install the tool by running the following command from the etcd source directory. The installation will place executables in the go path /bin. If go path environment variable is not set, the tool will be installed into the home go bin. You can also find out the installed location by running the following command from the etcd source directory. So make sure the path is set accordingly in your environment. All right, so once you run that, it says the following command will output the usage per the latest development. So benchmark -- help for more information on how to use this tool. So what's the actual question under this performance section? They ask, what does the etcd warning apply entries took too long mean? So after a majority of etcd members agree to commit a request, each etcd server applies the request to its data source and persists the result to disk. Even with a slow mechanical disk or a virtualized network disk, such as Amazon's EBS or Google's PD, applying a request should normally take fewer than 50 milliseconds. If the average apply duration exceeds 100 milliseconds, etcd will warn that entries are taking too long to apply. Usually this issue is caused by a slow disk. The disk could be experiencing contention among etcd and other applications, or the disk is simply just too slow. For example, a shared virtualized disk. To rule out a slow disk from causing this warning, monitor the backend commit duration in seconds. So when we click that link, it takes us here. These metrics describe the status of the disk operations. All these metrics are prefixed with etcd disk. And so to dive in a little bit more, it says a wall fsync is called when etcd persists its log entries to disk before applying them, and then a backend commit is called when the etcd commits an incremental snapshot of its most recent changes to disk. And high disk operation latencies wall fsync duration seconds, or backend commit duration seconds. So a high number of these often indicate disk issues. So it may cause high request latency or make the cluster unstable. Okay, so monitor that. P99 duration should be less than 25 milliseconds. To confirm the disk is reasonably fast. If the disk is too slow, assigning a dedicated disk to etcd or using faster disk will typically solve the problem. The second most common cause is CPU starvation. If monitoring of the machine's CPU usage shows heavy utilization, there may not be enough compute capacity for etcd. Moving etcd to dedicated machine, increasing process resource isolation C groups, or renicing the etcdserver process into a higher priority can usually solve the problem. Wow, moving etcd to a dedicated machine. More expensive user requests which access too many keys, for example fetching the entire key space, can also cause long applied latencies. Accessing fewer than several hundred keys per request, however, should always be performant. If none of the above suggestions clear the warnings, please open an issue with detailed logging monitoring metrics and optionally workload information. Alright, and I'll stop today's video there. In the next one, we'll go ahead and cover this warning: failed to send out heartbeat on time.